Assalamu alaikum, this is Shazad from Gazen Academy Senior Campus, Kishanla, and I welcome you all to FBISE online support program. This is our 7th lecture of 3rd week on the topic of programming techniques. We are talking about the chapter first, and this is our almost last topic of this chapter. In this lecture, we will revise the concept of algorithm, what was the algorithm and how to create an algorithm, what is the role of the algorithm, why we create an algorithm. Then we will introduce the new topic, which is flowchart. What is the flowchart, how we use, why we use, we will discuss in detail. Then algorithm versus the flowchart, what is the difference between algorithm and the flowchart, we will discuss in detail. Then the importance of the flowchart, what is the importance of flowchart, why we have to create the flowchart for our program techniques. Then we will discuss what are the steps to draw a flowchart, and at the last I will create a quick summary for you. So let's get started. This is our chapter first. It includes three main topics: understanding the problem, algorithm. We have covered all these all these two topics. Now our topic is the flowchart. So let's get started by a revision of the algorithm. Algorithm means method. Algorithm means the method, procedure, technique, plan, or anything or any idea which is used to solve the problem. Algorithm is a step-by-step problem solving method that is easy to understand. So algorithm includes these main points. For example, algorithm is a complete package. Algorithm not only a single step, but it is a sequence of steps. It is the complete package of steps which is used to solve a problem. Then it have different steps. Not all the steps are same, but the steps are different. Then we need to perform these steps in a particular order to get our solution file, to get our problem to be solved. Then an algorithm results in a solution. After completing an algorithm, after the completion, algorithm gives us the solution of the problem. And algorithm should be easy to understand, which is the most important factor. If the algorithm is as much difficult as the coding is, then it is not necessary to create an algorithm. We can directly code the problem into the programming language. So algorithm must be easy. If we are creating the algorithm, it should be easy to understand by common people. Now what was the role of the algorithm in the problem solving? Algorithm plays an important role in the computer programming. Computer programming is the process of taking an algorithm and coding it into a language. Algorithm is simply writing on the paper what we need to do before creating any software, any program, any website, or anything else which we are going to create. So it is just a matter of information, matter of guidance which we want to do in the program or in our software. So we have to write it down in easy language in different steps. So algorithm will be the step-by-step procedure. If we have created step-by-step procedure, we have to just follow this procedure to get our result. For example, if you're going for shopping, if you're going to shopping to buy something, you have almost 10 to 20 items to purchase. If you create a list of these items, it will be very easy for you to purchase all the items very quickly. But if you don't have a list, then you have to remember every time you purchase a new thing. But if you have a list, you will take that item you have purchased and then you go for the next item. So it will be very easy for you to purchase all these things if you have a list of all these things which you want to purchase. So algorithm work in the same way. If you have all these steps on a paper, then you have to just follow these steps and create a program. But if you don't have any kind of idea before creating the program, you will be stuck up in creating program and you will waste most of your precious time thinking about what to do and what not to do. So before going to anything, before going to start anything, you must have an idea, you must have a plan, you must have an algorithm. In the technical word, you must have an algorithm before coding of any real kind of project or any kind of C project or any kind of software. So that was the role. Algorithm is important before starting anything. You must have an algorithm so you may do these things right in the right way. Otherwise you will waste most of your time remembering what to do and what not to do. Then how an algorithm is efficient, and how can we judge what algorithm is efficient and what algorithm is not efficient? The efficiency of algorithm is the property which relate to the algorithm. It is based on the computational resources used in it. If an algorithm must be analyzed to determine the resources used. For example, if an algorithm runs very fast and uses less RAM amount and uses less space requirement, this algorithm will be very best, and we will judge on the algorithm on the resource usage. For example, time, memory and storage space. For maximum efficiency, we wish to minimize the resource usage. If we want an algorithm best for our computer system, it must use minimum amount of RAM, minimum amount of CPU and minimum storage space. Then we will say that this algorithm very best and it runs in a very high speed and a very fast speed. Only in this way an algorithm is best for us. So now we'll go to our next topic, example. For example, algorithm example. This is a problem. Find the sum product average of 5 numbers. This is a problem and it have a very easy solution. For example, if you want the sum product and average of 5 number, you must have 5 numbers. The first step is understood by all. You must have 5 numbers, and then if you have 5 numbers, you have to sum them, then you have to multiply them, and then you get the average. So this is very easy, but we have to write it down in this way. For example, step 1, let's start. We have to start the thinking and let the 5 numbers be A, B, C, D, E. So we have the numbers 2, 5, 8, 4 and 12. Now what to do with these numbers? We have to find the sum, so we will plus all the numbers, we will add all the numbers and it will give us the sum. Then we have to find the product, we will multiply them all and we will have the product. Then step 4, find the average. We have already added all these number into one place, which is sum. We have already sum all these number. Now we just have to divide these numbers on. So we have assuming 5 numbers. For example, in the problem they told us that the 5 numbers, so we will divide the sum on 5 and we will have the output of the average. Now we have 3 outputs, sum, product and average. Then step 5, we have to only output this in a written form. We are not coding in any language, but we have to just write it down like here, like in this. And you will be very happy to know that there is no standard for writing algorithm. You have not to remember any algorithm, you just create it in your own language. No one can be make it error, or no one can make you a mistake that you have not followed the standard. There is no standard for writing algorithm. Algorithm is written in general way by the general people. So writing an algorithm is very easy. We just have to find out what is the problem, and then we have to write it in our own way in steps. So this is the example of algorithm. Now we will get the next topic, which is flowchart. A flowchart is also the solution of the problem, but not in the algorithm form. It is in the pictorial or diagrammatic form. Now I will read the definition. Flowchart is the diagrammatic representation of an algorithm. It describes what operations are required to solve the given problem. Same like the algorithm, it requires steps. It requires what operations. Operation means what are the steps to solve a problem. So we will discuss the algorithm, we will discuss the flowchart next to this problem. For example, last time we had a problem that find the sum, product and average of first 5 numbers. Now we will do this thing in a flowchart. First of all, we have to start a program, and if we have completed our operations, we have to stop the program. These are the understood steps. Next thing is we have to input the data. We need 5 numbers, so we will input 5 numbers, A, B, C, D, E. We will have 5 numbers. Then what to do? We have to process all these numbers. For example, we have to find the sum, we have to find the product, we have to find the average, and then we have to output the results and stop the program. This is the flowchart. Flowchart is the most easy way to code a problem, to model a program into a real solution. Now I will show you at the glance the both of the problem is same. Find the sum, product, average of 5 number. There are 5 steps, 6 steps. For example, we have to start, we have to add these numbers, and the same problem is coded in the flowchart form. So first step is start. We have the start in the flowchart too. Then we have to get 5 numbers, for example A, B, C, D, and flowchart also have the input process which will get the 5 numbers. Then we have to process in 2, 3, 4 steps. Find the sum, find the product, find the average. It also have some processing. Find the sum, find the product, find the average. Then we have to output. The flowchart also have an output. Then we have to stop. The flowchart will also have a stop. So flowchart and the algorithm are both the solution of a problem. There is nothing different between, but also the shapes only. This is the textual form of a problem solution, and this is the pictorial or diagrammatical form of a solution. So usually people usually think that the flowchart is easy to draw as compared to algorithm or the pseudocode. This is actually called the pseudocode. If we write an algorithm in the form of text, it will call the pseudocode. Now why flowchart is important? If we have an algorithm there, why we need to code in, why we need a flowchart to get the problem's solution in the pictorial form? A very simple answer is there. If we are a programmer or we are educated person, we will understand this text too, but a common people which is giving a project of creating something to us, it will not understand what we have to do for its project, for his project. So we need to understand that person what the project is about. So for the understanding purpose, we need to draw the flowchart for the understanding of the client, for the understanding of the developer, and for the understanding of complex problem. We need to draw the flowchart. Now I will read it. Flowchart illustrates the sequence of operation to be performed to solve a problem in the form of diagram. First of all, it is important because it's in the form of a diagram. Diagram are already very useful for every field of life, so we understand something very quickly if we are getting the diagram for that. For example, someone says that a picture is the 100 times better than the text. If we get the picture, we will understand very quickly, and if we have to read the text about something, we don't understand it very quickly. So it is a diagrammatic form. It is important. Computer programmer draw flow charts before writing the computer program. Before writing the computer program, he will draw the flow chart, what to do and what not to do. It provides an easy way to analyze and find the solution of the problem. For example, I'm talking about an analogy. Analogy means the similarity between two things. For example, it is considered that the construction of a building and a programming is in an analogy. If we have to construct a building, it is same like constructing a program or a software. So if we have to construct a building, we must have a plan. We must have a plan how many floors are to be constructed and how many rooms in each floor should be constructed. If we don't have any kind of plan, what will we do? We will do nothing, and we will not be answerable to mason, constructor or our contractor. So we must have a plan. In the same way, before coding any software, before creating any software, we must have a plan what we have to do and how should we have to do that thing. So once the flowchart is drawn, once we have drawn the flow, it becomes very easy to write the program in any high level language. Once we have the map, for example, in the construction example, if we have created a map, if we have created a very blueprints, sketches for our building, we have calculated all the things. We will create 3 floors, and in the 3 floors we will create only 6 rooms in each floor, and we will create the rooms of the height this and that, and we have these things in our rooms. So it is now only to follow. We have to only give the sketch to the contractor and it will deal that all. So creating a plan is most important as compared to creating a software. We must have a plan before creating any kind of software or any kind of instruction. It becomes very easy to write the program in any high level language. It is very helpful in communicating the problem solving method to the other people. If we have to understand the problem to other people, we have to make understand the other people of the problem. We may simply create a flowchart and it will help the people to. It also helps in finding and removing error in the computer program. If we are creating a very complex computer software, then the flowchart is very helpful for us, because very complex problems cannot be solved directly on coding or on algorithm. So we have to create the flowchart of that problem. Now we know what is the flowchart, what is the importance of the flowchart. Now we have to learn how to draw the flowchart. First of all, we need 4 things. The flowchart developer must determine the following requirements to be given in the problem before writing a flowchart. It should be known that the programmer or the flowchart person or the developer must know what are the input. For example, if we are talking about the problem finding some product average of 5 numbers, the input are the 5 numbers which we have to create some program, some solution of that problem. So we must know about what are the inputs. Then what type of processing is required. We need a if-else structure, we need a looping structure, we need a sequence structure. We must decide what kind of programming. In the processing, we need the formulas, what to do for the solving problem. These are the inputs and what to do with these inputs. Next we have to make a decision what type of structure we will use. We will use a sequence structure, we will use a if-else structure, we will use some looping structure. These structures will be discussed later in next chapters. In this chapter, you just remember that there are 4 stages. First step is the input. The user needs to get the input. Then it should be understood that what type of processing is required and what decisions to be made. The result to be produced after the processing, and we need the output. The output result should be processed after processing. So first step is input. The flowchart developer must know what exactly the input to the flowchart is. The input is determined from the problem statement. For example, the given problem is to convert temperature from Fahrenheit to Celsius. If we need to convert the temperature in the Fahrenheit to Celsius, we need the temperature in the Fahrenheit. Here the input will be temperature in the Fahrenheit. The input is only the data which we will get from the problem. Then processing. The flowchart developer must decide what type of calculation is to be performed or which formula is to be applied to obtain the required result. For example, to find the area of a triangle. For example, to find out the area of a triangle, what to do? We just have to divide. We have just to multiply the base with height and then divide it by 2, and it will give us the area. So output will be there if we applied these processing or this formula. The next thing is decision. Decision is the important aspects. The flowchart developer must decide which control structure, sequence, repetition or selection are to be applied for the solution of the problem. For example, selection structure must be applied to print a letter grade of the student based on the mark obtained. Selection structure will check which range the mark will fall and accordingly print the grade. For example, I will give you an easy example that selection structure is used to select between two values, what value to be select. For example, if you are trying to open your Facebook account, it will check your username and password and select whether you are suitable to log in or not suitable, whether you are authorized or not authorized. This is the simple implementation of a selection structure. You will give the username and the password, and the program will select between you whether you are required, whether you are eligible to log in or not. If you have provided right email, right password, then you are eligible, otherwise it will give an error message. So this is the example of a simple selection structure. If you have to repeat the things very quickly, and most of the time we will need the repetition structure, and if we need to do nothing, just to write line, you will use this sequence structure. This concept will be discussed later. There are a whole chapter on each of the structure. Don't be panic, it will be in next chapters. The final thing, if we have input the data, then we have processed the data and we have decided what to do. Now the last step is output that solution. Show the solution or show the result to the users. Output. The flowchart must provide the required output. Now I will make a quick summary for you. We have discussed that what is the flowchart. Flowchart is simply a diagrammatic representation of an algorithm. Algorithm is the textual form and flowchart is a diagrammatic form of an algorithm. It describes what operations are required to solve a problem. It only describes what operations are required to solve a problem. These are also the step-by-step procedures. Now the flowchart must have 4 steps. Before drawing the flowchart, we must have to apply 4 steps. There 4 steps are the input step. We must have an input. Then we have to process that input by making some formula, by applying some formula, by doing something, or by making some processing. And then we have to decide what kind of structure, what kind of coding standard will be used, and then we will show the output to the audience. If you feel any confusion in today's lecture, you will let me know in the group. And this is all the lecture of today. Thank you very much, and Allah Hafiz.